electronic circuit series we are discussing the various components. Today we are discussing the multimeter, and this multimeter is used just to check the various parameters in the electronic circuit, and this is very important device. Just at the instant we can measure the fault in the digital circuit. So this multimeter is having the various part that we have discussed. Now what symbols that are mentioned on the multimeter that we will discuss. There is mentioned V, that is for the voltage, A for the alternate current, and ohm for the resistance. So apart from that, there are the various symbol like multimeter. In the multimeter symbol that you have seen, that this is a Swiggy line. The Swiggy line represent the AC alternate current. So you have seen the Swiggy line next to or above the voltage or current. You have seen in the diagram that this Swiggy line at the V, that is approximate that this Swiggy line represent the alternating current. So in addition to the metric prefixes, they stand for the alternating current. So this voltage in the AC circuit is usually referred to the AC voltage, even though it stands just to say that alternating current voltage. So AC circuit, in the AC circuit it is a AC voltage. So you can see that these settings when we are measuring the circuit with the alternating current or the voltage. So this symbol is represent the alternating current. Another you have seen that there is a solid or dashed line. So this solid and dashed line represent the that straight line represent the direct current. So the Swiggy line you might have seen just next to the V and A. Similarly here we are having the straight line or the dotted line or the dashed line just near the V or A, that represent the direct current. And these settings when we measuring the circuit with the direct current. Most circuits that are powered by the battery using this straight line or the dashed line. Sometimes instead of the addition to using the Swiggy or the dashed line, the multimeter will use the abbreviation like AC and DC. You have seen that DC voltage, AC ampere, DC ampere, DC current, V, VAC or DAC voltage in the form of the AC or the DC. So there are the various abbreviations just mentioned on the multimeter, which stand for the alternating current and direct current respectively. So multimeter might have the AC and DC after the V and A instead of before. So that is the symbol. Now you have seen that there is a one symbol that is used for the continuity check. So series or the parallel arc you can see here. That this arc represent the continuity check. So this setting used to check the two things are electrically connected or not. If it is connected, it will give the beep. If it is not connected, the beep will not be produced. So multimeter will beep if there is a connective path between the two probe tips, that measuring the resistance at every close to the 0, and it will not make any noise if there is a no conductive path. So so sometimes the continuity check can be combined with the other function on the single setting. So you can see that this is like a curve. Another is the diode check, that is also represented by the triangle with some line through it. You are seeing on the screen that there is a diode symbol and a line is mentioned before it. So this function is used to test the diode, which is like a one-way valve for the electricity. So it only lets current flow in the one direction. So the exact function of the diode check can be different or different on the different multimeters. You have seen that here, that check the multimeters manual to just check that what they have mentioned for the diode check. There are the various type of the symbol used for the diode check. Then another point is what is this red and the black wires, and when do it plug with the there are the two there are the three port, and where these port are used just to measure the various value. So in the multimeter probably come with the red and the black wire that look something like the one that we have seen in the figure. So these wire called the probes or the leads, or sometimes the leads. We have the one end of the lead is called the banana jack, and this end plug into the multimeter, and that sometimes multimeter have the pin jacks, banana jack and the pin jacks. Two type of jacks are attached according to the device which we are measuring, according to the electronic device which are used for measure the value. So which are smaller than the banana jack, that are the pin jack, that are at the front of the probes, and if we need to replace these probe, then easily it can be replaced. You see here in this diagram, these are the point probes. So probes tips used to just test any circuit. So the other end is called the probe tip. And this is the end used to test the circuit, as these two probes are connected with the circuit, and these two, and you can see there is a banana jack, that jacks just to plug into the multimeter. Multimeter having the knob, and these banana jacks just put in this knob. So one is black and one is the red. Although they come with the two probes, so many multimeter have more than the two places in which the plug the probes, which can cause some confusion. So that these two, but according to the measurement, they are just mentioned in the manual. So exactly where the plug the probes in will depend upon what we want to measure, like voltage, current and resistance. So continuity test or the diode test, that type of multimeter have these type of description, where we are just put these probes in the plugs. So it provides the one example that we are having a just we check the multimeter beep. So we put in the common, we put one in the common and one for the that black just put in the common and red in the resistance. So most multimeter have fuses to protect them from too much current. So these fuses burn out, too much current flows through the circuit in the multimeter, so they stop electricity from the flowing and prevent damage of the rest of the multimeter. So fuse is also there in the multimeter. Some multimeter have a different fuses depending upon whether which we are measuring high or the low current, which determines where we can plug the probe or not. So just for example, the multimeter having the one fuse for the 10 ampere and the one fuse for the 200 milliampere, one for the high voltage, high current, and another for the low current. You are seeing that the both the value are plugged for the different knobs. So that is defined for the 200 milliampere, you see, and as well as just we use the to 10 ampere. So it is just changed, the position has been changed, that will define the range. Now how we measure the voltage through the multimeter? Now how we measure the various parameter? First we measure the voltage. So what are the steps to measure the voltage through the multimeter? So first just plug the black and red probe into the appropriate socket, that is the port in the multimeter. So the most multimeter have a black probe should be plugged into the socket level to the COM, and the red probe just put into the socket which is labeled as the V. It might we have the some other symbol, but it is the voltage, as we are measuring the voltage. So they are mentioned, the most of the multimeter having the symbol V. So remember, just to check out the image gallery, how the multimeter overview section and the multimeter manual have the just having the point that will define that these knobs are connected with internally, how these knobs are connected, that we can check through the manual. Now choose the appropriate voltage setting on the multimeter dial, as there are mentioned a particular value from 20 volt to the 200 millivolt. So that value is adjusted through the knob. Now the most battery powered circuit will have the direct current, but the setting of the selection will depend upon the value which we are measuring. So if we are working with a manual ranging multimeter, so we have to just estimate the particular range on the basis of battery which are used in the circuit. For example, if the circuit is powered by the single 9 volt battery, so it probably does not make any sense to select the setting for the 200 volt. It means 2 volt would be the too low. So as we are using the 9 volt battery, so we select the 20 volt. Up to the 20 volt, so we can measure the voltage of the 9 volt battery. So by choosing the particular appropriate value, we can measure the required result. So touch the probe tips to the circuit parallel with the element, we measure the voltage across it. Multimeter, just explanation of the series and the parallel circuit, we can have the various value. As we see in the diagram that the voltage drop across the light bulb powered by the battery. So we showed the use of the red probe on the side connected to the positive battery terminal. So our black probe on the side connected to the negative battery terminal, that will give the value. Now you see on the screen that the battery is connected positive with the red and the negative with the black. Now you see, connect the multimeter in the parallel to measure the voltage drop across the light bulb. As the light bulb is glowing, so that voltage drops, so we can measure through this, just connecting the circuit with the parallel to the multimeter. So the multimeter is not the auto ranging, so we adjust the range. If it is auto range, so it will give the value directly. So if the screen read the over OL, it means our range is high. So we have to adjust the range according to the value or the battery which we are using. Now the second part is the how we measure the current flow. Again, just we connect the black and red probe into the appropriate socket on the multimeter. For the most of the multimeter, the black probe should be plugged into the socket which is labeled to the common, that is the COM, and there might be a multiple socket for measuring the current with the labels like the 10 ampere or the milliampere. So it is always safer to start out the socket that can measure a larger current. So plug the red socket into the high current port so that the value can be measured. Now choose the appropriate current setting on the multimeter. Just we remember, just to check the circuit is direct current or alternate current. So accordingly we adjust the multimeter at the direct current or the alternate current, and almost all battery powered circuit will direct current having. So if the meter is not auto ranging, so again we have to adjust the scale according the power we are using and the reading we will get. So multimeter probe just connect in the series just to get the current. So you can see on the screen, you are seeing that how these probes are connected just in the series to measure the current. So connect a multimeter in the series to measure the current flow through a light bulb. So multimeter is not auto ranging, so we have to adjust again. If it is show over OL or 1, it means there is a overload. So again we just increase the range of our circuit. So again the third point, how we measure the resistance. Again we are having the two knobs, one is red and another is the black. The black connected with the the black probe connected with the COM, and the red just plug with the symbol in the socket, that is ohm. The red just put in that circuit. So appropriate resistance measurement can be done by selecting the particular value. If we estimate the resistance by measuring the voltage and the current, so for example if we measuring the resistor with a known value, which will help to pick up the range, that at which range we can adjust it. So that is an important point, the turn off the power supply of the circuit before measuring the resistance. So if the circuit has a power switch, so the turning the switch off. If there is a no switch, so remove the battery, but the power should be off. First we take the reading. Otherwise then just we check the reading after the power on. If the circuit has a multiple components, so we might need to remove the components we want to measure. The order of accuracy determine its resistance. For example, if the circuit has the two resistors in the parallel, so we will have to remove the one resistor to measure their resistance individually. So connect one of the multimeter probes to each side of the object, then we choose the resistance just we want to measure. So resistance is always positive and the same in both the direction. So it does not matter if we switch the black or red probe in this case, unless you are dealing with the diode, which acts like the one way valve for the electricity. So it has a high resistance in one direction and the low resistance in the other direction. So you see on the screen that this is the disconnect the power supply to measure the resistance of an object. So this object, by using this object we can measure the resistance. Another, the multimeter is not the auto ranging, so again we have to adjust the range. If it is show the over or the value 1, it means it is out of the range. So this happens, we adjust the range up or down as we required. So remember that we might need to consult with the multimeter manual for the specific about the value. Another important and the quick check is the continuity check. So how do we check the continuity of the circuit? So just to check the continuity of the circuit, there are the various steps. Number 1, just set the multimeter to the continuity check symbol. It is very simple process just to check the continuity. First, just set the multimeter to the continuity check symbol. Now the symbol might not look like the same in all the parameter, but there is mentioned that is a continuity check, and most of the multimeter have the continuity check in the multimeter. So the check out the multimeter, so overview that we are having the plug the probes into the appropriate socket. On most of the multimeter, the black probe again just connect with the COM and the red just go into the same socket as we measure the voltage, resistance or the current. So the turn off power supply to the circuit then continuity check we can do. So if the circuit has a power switch, then we can do this by turning the switch off. If there is no switch, then remove the battery. Again, touch the two part of the circuit with the probes. When it is touched with the probes, so the two parts of the circuit are electrically connected with very little resistance between them. The multimeter should beep. If they are not connected, it will not make a noise. So it might display something like OL over or 1, that is the value is high. So the easiest way to test this function with the multimeter is to check with a single piece of conductive material. Most of the metal we can use and piece of the non-conducting material like wood or the plastic. Just you see here in the diagram, if the conductive path is formed, the multimeter will beep, otherwise there will be no beep. So through this way it is connected with the two connectors. So in this way we can measure. Now you see, this is the discontinuity. Now the conductive path is broken. Now no beep will be there. So when it is connected, so beep will be there. When you see the device is broken, so there is a no beep and there is a discontinuity in the circuit. So using the multimeter we can do the continuity check. If the conductive path is formed between the probe tips, the multimeter will beep. If the conductive path is broken, so multimeter will not beep. So this is the how the knob has been set to the symbol for the continuity, and the red probe is plugged into the voltage ohm, and this port is not always labeled with the continuity symbol. So you can see on the screen there is another type of the multimeter also, which can measure the various parameter. So DC voltage setting here. So there are the various parameters just are used for measure the current. This is the another type of multimeter you can see. So we are having a different type of multimeter that can be used for the different purposes. Now they are having a different type of knob and different type of parameters we can measure by using the various. Now you can see this is the one of the another type of multimeter that is used for measuring the various parameter in the electrical circuit. So these are the, so what can multimeter measures? We have discussed that we can measure the voltage, current, resistance. Through the multimeter we can check the circuit breakage in the circuit, in the electronic gadgets. We can also check the circuit. So multimeter can check the continuity of the circuit. Moreover, the connection of the wires are properly adjusted or not. Some multimeter have a diode check also, diode check function also. So diode is like the one-way valve that only lets electricity flow in the one direction. So the exact function of the diode check can vary from multimeter to the multimeter. So advanced multimeter might have the various functions like ability to measure and identify the electrical components like transistors, capacitors, and since not all the multimeters have these features, so some specialized multimeter are used to measure these devices. So some of the references we have used for this purpose. Thank you very much.